late 20th century, the philosophy of science faced a crisis. Karl Popper had argued that science advances through falsification, bold conjectures tested and refuted. Thomas Kuhn countered that science moves through paradigm shifts, long periods of normal research punctuated by revolutions. One emphasized logic, the other emphasized history. But could both be right? Into this debate stepped Imre Lakatoz, a philosopher determined to reconcile rationality with scientific practice. Lakatoz began as a student of Popper, but he recognized a problem. Popper's early version of falsificationism suggested a theory makes predictions. If a theory fails, the theory is falsified. Rational scientists abandon it. But history does not work that way. Scientists do not discard major theories at the first anomaly. Newtonian mechanics survived numerous discrepancies. Astronomical irregularities did not immediately overturn gravitational theory. Lakatoz argued that naive falsificationism misunderstands scientific resilience. Lakatoz took seriously the insight associated with Pierre Duhem and Willem van Orman-Quine. Experiments do not test isolated hypotheses, they test networks of assumptions. When prediction fails, we cannot determine with certainty which component is responsible. Thus, strict falsification collapses. Scientific theories are not abandoned instantly, they are adjusted. The question becomes, when is theory adjusted rational and when is it ad hoc? Lakatoz's central contribution is the concept of a research program. Instead of evaluating isolated theories, we evaluate structured sequences of theories over time. A research program consists of 1. The hard core, the fundamental assumptions of the program. These are protected from direct refutation. For example, in Newtonian mechanics, laws of motion and universal gravitation. The hard core is not immediately abandoned. 2. The protective belt. Surrounding the hard core is a set of auxiliary hypotheses. These can be modified to accommodate anomalies. Adjustments occur here, not at the core. 3. Heuristics. Lakatoz distinguishes negative heuristic, do not question the hard core, and positive heuristic, guidelines for extending and developing the program. This structure explains why science can tolerate anomalies without collapsing. Lakatoz's key evaluative criterion is historical and comparative. A research program is progressive if it predicts novel facts, it leads to new discoveries, theoretical development precedes empirical confirmation. Degenerative if adjustments are merely ad hoc, changes respond only to already known anomalies, no new predictive successes occur. Rational theory choice, then, is not instantaneous. It depends on long comparative progress. Science advances not by isolated falsification, but by competition between research programs. Lakatoz preserves Popper's emphasis on rational criticism, but modifies it. Where Popper emphasized immediate refutation, Lakatoz emphasizes comparative historical evaluation. Falsification becomes sophisticated. A theory is not rejected simply because of anomalies. It is rejected when a rival program demonstrates greater progressive power. Thus, Lakatoz defends rationality without ignoring scientific complexity. Lakatoz also critiques Kuhn. Kuhn's paradigms involve sociological shifts and incommensurability. Lakatoz feared this drifted towards relativism. For Lakatoz, there are rational standards of theory evaluation. Competing programs can be compared. Progress is objective, not merely sociological. However, Lakatoz adopts Kuhn's insights that scientific change is not instantaneous and not purely deductive. In this sense, Lakatoz attempts a synthesis: Popper's rationality and Kuhn's historical realism. Lakatoz introduced the idea of rational reconstruction. The historian describes what scientists did. The philosopher reconstructs how scientific development ought to be understood in rational terms. Scientific history, in practice, may appear messy, but philosophical analysis can reveal an underlying structure of rational competition. Lakatoz's philosophy thus bridges normative methodology, historical case study, and logical analysis. Lakatoz's framework shaped the 20th century philosophy of science. It influenced debates about theory of change, scientific realism, and methodological pluralism. His work also provided an important counterpoint to Paul Feyerabend, who rejected structured methodology altogether. Where Feyerabend embraced anarchism, Lakatoz defended structured but flexible rationality. Imre Lakatoz offered a powerful reimagining of scientific rationality. Science is not a series of isolated hypotheses, nor is it purely a sequence of sociological revolutions. It is a structured competition between research programs, each with a protected core, adaptable strategies, and long-term trajectories. Rationality lies not in instant falsification, but in progressive problem-solving power. Lakatoz reminds us that science grows not simply by refutation, but by disciplined, historically extended comparison.